All right, so I decided you are ready for this. The calculus chart of awesomeness. It is attached to this lesson now. And yeah, what this chart does is it tells you what the graph of f is doing, what the function f is doing, what f prime is doing, and what f double prime is doing, and how they're all connected. So a lot of the things that we observed as conclusions to this sheet are summarized here. So for example, when f is increasing, f prime is positive. That's an if and only if the arrow goes both directions. When f is decreasing, f prime is negative. All right, so those are your sort of your most basic observations. Some other basic observations, for example, when f is a positive function, the graph of f is above the x-axis. When f is negative, the graph is below the x-axis. When f is 0, f has an x-intercept. When f prime is 0, f could have a lot of different things. F has a horizontal tangent, and it could have a max, min, or a point of inflection. F prime undefined, we haven't talked about yet. That's 3.2. I'll come back to it later. When f prime is changing positive to negative, this is an if and only if, f has to have a max. We don't know whether it's local or global, though, and that's going to be a thorn in our side. When f prime is changing from negative to positive, f has to have a local or global min. When f prime is increasing, f is concave up, and f double prime is positive, right? So blah, 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 that's how it works. By the way, something that I threw in here is that when f double prime is 0 and changing sign positive to negative, so that f prime has a max or min, then f has something called an inflection point, which I haven't really talked about. An inflection point is a point where f changes concavity. All right, so that means it changes from concave up to concave down or vice versa. So we call that a change in concavity. That's called an inflection point. We'll talk a lot more about that later. I threw in here the average rate of change, f of b minus f of a over b minus a. You flip this puppy over. This is the first calculus chart of awesomeness. Flip it over. Here's the second calculus chart of awesomeness. This now relates position, velocity, and acceleration. So I invite you to, peruse this at your leisure and include it with your notes. It says things like when s is positive, the object is to the right of 0. When s is negative, the object is to the left of the 0. This also could be above or below if we're going left or right. So I put everything in terms of left or right, but you could change all those to up or down, right? When s prime is positive, so s prime is the velocity. It tells you s is position, s prime is velocity, s double prime is acceleration. We talked about that. When s prime is positive, the object is moving to the right or up. When s prime is negative, the object is moving to the left or down. When s prime is 0, the object is instantaneously at rest and may be changing direction. When s prime changes positive to negative, s is changing direction. The object is changing direction. When s prime changes negative to positive, the object is definitely changing direction. And etc. So we're accelerating to the right, accelerating to the left, blah, blah, blah. You can read all that. It's great. Anyway, so I'm posting this and including it. There's the calculus chart of awesomeness. You're welcome. Next, this is something the AP exam loves to have you do. Here's the graph of f prime. They want you to sketch the graph of f. All right. Now, by the way, I said in all of these, I said sketch the graph of f. This, by the way, this worksheet is attached as, I think it's called Graphing Practice f prime. You should look at that now, download it now and sort of go through this with me. All right, so hopefully you've had a chance to do that. So we'll go through the first one together and then we'll push the rest to the next video. So look, this is showing f prime. So what is f doing if I know that this is f prime? So I can think about things on this chart. So for example, like one of the crucial things in these kind of things is find the maxes and mins first. You find the maxes and mins and you've got the whole thing. So we want to look for where f prime is changing positive to negative, that's a max. Where f prime is changing negative to positive, that's a min. All right, so what I see right here at this point at x equals 3, f prime is changing from negative to positive. Now, that means that f has a min there. So I don't know what the y-coordinate is, but at x equals 3, the function has to have a min. All right? Now, here's a fun thing. Because remember that the derivative is invariant under vertical translations, that means I don't ever know where the y-coordinates is. All I know is where are the features in their terms of their x coordinates. All right, so I know f has a min here at x equals -3. I know that for a fact, and that's really all I know. But I also know that since f prime is negative in this whole region from -∞ to -3, f prime is negative, that means f has to be decreasing. So remember, that doesn't mean like, right, it means like this, because when we say decreasing, you're always going to the right on the x-axis. So here's what f decreasing looks like, all right? Now also, f prime is increasing on this interval. Therefore, f is concave up. In fact, f prime is increasing over the whole domain. Therefore, f must be concave up on the whole domain. So we know f is concave up. We know f has a min at x equals 3. We know that at x equals 3, f changes from decreasing to increasing. So now, from now on, f must increase. It must increase, and it must be concave up, so it must look like a parabola. All right, and that's really all we know. We know that it's a parabola, and we know that f is a parabola, and that it is concave up, and that it has a min at x equals -3. But remembering that all we know is the derivative, and the derivative is invariant under vertical translations. Remember, there are many possible solutions. So this is also a possible graph of f. And it could be tighter, right? We don't know. It could be like a really tight parabola. We don't know. But what we do know is whatever we draw has to have a min at x equals -3, has to be always concave up, because f prime is always increasing, has to be decreasing on -∞ to -3 and increasing on -3 to infinity. So these are all different possible graphs of f. Of course, you could also, draw it lower. You could draw it broader. These are all possibilities for f. So your job on each of these is to draw one possible graph that could represent f. And a lot of times they'll phrase that way in the AP exam. So it says sketch the graph of f. I really should say sketch a possible graph of f. So just one of the possibilities, all right? So you think about how number 3 might look, but I'm going to go through in the next couple of videos number 3 and 5 and a couple of the other ones, and your job is going to be to finish it for homework.